He's one of our best instructors.
Really?
We're not picky at all.
Let's teach you how to make pizza.
I don't think she's done too much with it, but she's in China for a month and has been because we've been expanding this project to about 8 or 9 Chinese sites, which will eventually, we'll get cool data back from them. But she's been there setting stuff up. And
all right, welcome everyone. We can go ahead and get started. Tools and Technology Seminar Series. There's just a couple left for the semester, and then we will be taking a break for the summer and start up again in the fall. I'm, of course, always looking for speakers, so if anyone's interested in presenting in the fall, please let me know. Makes my life much easier. Anyway, pleased to present our speakers today. We have Srijan Sen, who is the Francis and Kenneth Eisenberg Professor of Depression and Neurosciences, Associate Professor of Psychiatry, and also Research Associate Professor for MB&I. And his co-presenter is Jamie Estill, who is the Business Systems Analyst Lead for HITS.
Thanks, Marcy. So hopefully we can have a good discussion. I'll just present a little bit about the overall project and the data types that we've been collecting, and then Jamie will go into all the cool stuff they're doing with the data virtualization. So, the overall goal of this project is to try to understand stress and the effects of stress and why, how it affects the body and why some people get depressed and anxious and suicidal and get infectious diseases in response to stress, and why other people tend to be resilient and handle the stress in different ways. So what we're doing for the project is using a specific group as a model for stress. First year physicians, so interns. So these guys are just finishing up medical school and starting off their first year as professional doctors. So each year around this time of the year, actually like a month ago, the end of March, the graduating med students here at Michigan and everywhere around the country found out where they're going to go to residency. They have this 3-month period or so where they're really excited and altruistic and think that they're going to save the world, don't know what they're in for. And then starting July 1st, they're going to start working 80 to 100 hours a week, getting yelled at by people like me, killing patients, which is stressful for patients, but also for the doctors. And so we sort of take advantage of this relatively unusual situation where we know that a group of people are going to encounter stress in a consistent and predictable way. So we're just starting to enroll our 11th cohort. We enroll about 3,500, 4,000 interns a year around the country, and assess them pretty comprehensively through about half-hour baseline questionnaire around this time of year, and then during the year we assess them at our sort of major assessments every 3 months with questionnaires, and we do this across medical specialties. So sort of the basis for most of the work we've done is this increase in depression. So before the year starts, about 3%, 4% of them meet criteria for depression. Once the year starts, at any given time, about a quarter of them meet criteria for depression. So a pretty dramatic increase in mood problems. There's a corresponding increase in suicidal thoughts of death, anxiety, a range of other sort of psychiatric symptoms. So we're sort of interested in understanding what's underlying that increase, and to do that, we've been you can sort of imagine that there's interesting questions to ask, and that this is acting on a whole bunch of different levels. So we measure a lot of psychological symptoms. This is just the questionnaire for depression, but we also measure other psychiatric symptoms. This is a list of the ones that that when we measure a baseline predict who's going to predict the increase in depression. So so there's a gender difference. There's a difference in neuroticism, which is our probably biggest predictor that people who are more neurotic measured before the year starts get a lot more depressed during the year. Well-being, lots of family history and early life experiences seem to predict depression. And then also we measure a bunch of factors during the year. So people who work more hours get more depressed. We measure sleep in different ways and outside stressful life events. So this is just sort of to give an idea of the type of questionnaire-based and survey data that we collect through the year. And then we also gather a lot of biological and other information. So all these guys provide DNA samples, so we do GWAS on them, mostly through this psych chip, which measures common variation, and then a little bit rarer exome variation. For a subset of the sample, we get 2 DNA samples, so a DNA sample before the year starts, and then a DNA sample towards the end of the year, and that allows us to look for some changes throughout the year. And what we're looking at with this is DNA methylation across 400,000 or 500,000 sites in the genome, and we can look for changes in methylation with the year of stress. There's cortisol is a stress hormone that goes up acutely in response to stress, but typically has been measured in saliva and blood, which has a very short half-life. In the last maybe 5 years, people have figured out ways of measuring cortisol in the hair, that sort of the centimeter of hair closest to your scalp reflects your overall blood levels of cortisol for the last month. So so each 2-month period or so, we go around the hospital and cut the hair of these doctors and measure the cortisol levels and follow them throughout the year. There's some pretty good evidence that depression increases your risk for heart attacks and strokes and other cardiovascular disease. None of these guys are having heart attacks, but we measure their cardiac function through a sort of evocative test and see that their cardiovascular function sort of declines with the year of stress and correlates with depression. So again, these individual measures aren't that important, but just giving a flavor of the type of data that we're measuring. We also, there's a longitudinal component to it. So some of these guys we measure not just through the 1 year, but follow them as they go out past internship, and now some of them are 7-8 years out of training, and their experience has changed. So the data also has a longitudinal component to it. And then more recently, the last 2 or 3 years, we've been collecting a really interesting but challenging data type of mobile data. So we've developed an app that sort of pushes notifications once a day, to get mood. So we asked people this question to rate their mood on a scale of 1 to 10. But we have that data for there's a good amount of missing data, but over the course of 365 days or even longer, about 400 days in the study. And then we have them wearing Fitbit devices and maybe eventually other devices, and pulling in data from those devices. They also, the app taps into the iPhone frequent location information, so pulls in the GPS coordinates of every place all these subjects go each day. So it's a huge amount of data, but hopefully valuable. So we can do some interesting analyses with the Fitbit data, measuring sleep. We can see sort of the blue lines are when. So before they start internship, they on average are waking up at 8 o'clock, but during internship that gets pushed back to 5 o'clock. But this, when the time they go to sleep doesn't change very much. They're still going to sleep at around 11. So you can see these guys lose a lot of sleep. There's also sort of relationships we can pull out of it between the mood and the sleep. You can see the two lines are pretty closely paralleling each other. Once internship starts on day 0, both mood and sleep go down. And we sort of, it looks like that there's a differential directional relationship. So how you slept last night really does affect your mood pretty strongly today, but vice versa, it's not true or not as true. So your mood today doesn't affect your sleep quality or time as much tonight. We just randomly stumble into stuff. So everyone got really depressed on November 9th with this daily mood data. And it looks like we have data now further on. People are more depressed now than they were before. Yeah, we can. Well, we see the drop in mood was much higher in California than it was in like Montana. So there was state differences. And then different groups, so women and people identified as LGBT got more depressed and are like continue to be depressed in February and March. So again, this isn't the main point of the project, but because of the data we're collecting, we stumble into interesting stuff. So most of the analyses we've done so far, as you can tell, are within a type of data, just sort of looking at how mood changes throughout the year, or methylation differences from before the year to after, and genomic changes. But I think there's a lot of interesting potential findings and work in if we have the ability to look across all these different types of data, from the psychological and daily mood and longitudinal and DNA methylation, genomic sequence, but we don't really haven't had the tools to do that. So that's when you guys come in and hopefully developing a methodology for doing that kind of work. So,
Is there any way to take into account sort of like the mood of different locations, like the group mood? So if you're in with a bunch of people that are bummed out because of administration or something, so
yeah,
like seem to feed in on.
Yeah.
Do you have?
I'm interested in doing that because there's some evidence that sort of mood is contagious, and and this could be a nice model to do it, because we have the mood of these people before they get into that situation, and then some of them are surrounded by bad administrations and
We don't have to make a term.
right. But we haven't found a really good way analytically to do that, but I feel like that's it's there to be done. But so I think we haven't done it yet, but it'd be cool to do. So if you have ideas, please let me know. It's hard to tease out at least what I've struggled with is the effects of the administration, sort of like you're saying, and the effects of the your co-resident. So both of those can affect someone's mood. So if I'm surrounded by just depressed people, I'm more likely to be depressed. But also if I have a
surgeon.
Right. And so trying to tease out those things is a little bit difficult, but I think it is interesting to do. So, yeah.
Oh, sure. Thanks. Sorry. Thank you. So I'm Jamie. I'm trained as a bioinformatician and a genome biologist. I did a degree at the University of Georgia and did postdoctoral work on studying some of the more difficult corners of eukaryotic genomes. And so from that, I now am an employee of Michigan Medicine. I work in the Health Information Technology and Services group. I formerly worked with MSIS, but we've since merged over the last few months. And I work in the Research Applications and Advanced Computing group. But really, the day-to-day work that I do is usually what you could call a data plumber. I work in a research data integration group And a lot of the work that we do focuses on how can we, as an institution, provide services for research data integration so that folks like Srijan can focus on the science instead of the data plumbing and the data integration work that would make his work more difficult, so that we free him up to spend more time on the ideation phase and being able to test hypotheses instead of wrestling the data into solutions. What I'm not is a person that did any of the work that I'm talking about today. So that's anything that comes across as a smart thing to do, we can thank these three guys. Anything that comes across as a White House press secretary on a bad day, I'll own that. The lead developer for this has been Amitav Shi. He was a research architect for the HITS group until a few months ago when he went to industry. And then a lot of the bulk of the heavy lifting was actually done by two interns in our group, Tim and Audit. Audit's HITS intern. He joined us his first semester on campus, but he came in as a junior that already know how to code Java really well. And Tim joined us last summer as well, and when he was in the middle of a master's in biomedical engineering. The tool that we use to help us do some of this data integration work, where we have data in a bunch of different places, is this thing called Teiid data virtualization. It's an open source tooling that allows you to connect to a number of different types of data, integrate those into a virtual database, and then expose those to data consumers in ways that are easy for them to access and integrate data, to where you see the data in sort of a front desk kind of situation where you don't have to worry about all the mess that's going on back in the warehouse. And if you really want to get back into the warehouse, you can also dive into the interface that we have for being able to wire data together in new places. It's able to connect to big data sources like a lot of NoSQL and Hadoop type data sources, as well as just an Excel spreadsheet or an Access database or a structured database in MySQL or SQL Server. It can also connect to cloud applications, but the key thing that it does is it brings all these things together, and you can create a virtual copy of that so that an analyst can connect to that virtual copy just as it would a SQL database where everything's in one space. So if you think about it, this can be kind of a lifeboat on the data lake for old school SQL programmers like me, where we can set a SQL front end on top of this Hadoop database that's in the back end. So you don't have to retool and relearn a lot of new systems to be able to integrate and work with data. You just kind of treat these data as just a regular SQL database where you have tables that you can join together, new types of queries. You don't have to worry about where the data are. And unlike a traditional data warehouse where the data are only as fresh as the last time you pulled your data in, this can connect to the live data at the source system. So when you really need to have up-to-date data, but you don't want to move everything over every few minutes, this is a way to present that as a data model where you can connect into the actual live data that's going on at the moment. It's also possible for it to connect to streaming data sources, where if you have data streams or RESTful data services that you want to integrate with structured data, you're able to do that as well. And then on the presentation side, the way that you can access those data is just as a regular SQL database where you can just write queries in sort of standard SQL. And it's also able to expose the data as web services, as JSON or SOAP web services. And it generally uses sort of the OData standard. If you haven't used that, it's sort of like REST with a little bit of structure to it so that you know what you're getting into. The nice thing about that is when you develop an OData service from this virtual database, it's literally just a click of the button. If you look at having to write bespoke code to be able to connect to a database and then surface those data as a service, you're usually talking about a few months of work. But with this, we can connect to a database and with the push of a button, rely on the engine to expose those data as an OData service. An example is that we had sort of a high-end Java programmer that was working for us for a while. When we're first starting to work with Teiid, we connected a data set up. He went and got coffee, and as a business analyst, while he was gone getting coffee, I was able to expose an OData service, connect to it with a business intelligence environment, and provide a visualization of the underlying data. So this was in like 10 minutes worth of effort the first time that I ever worked with the tool. I was able to take a database that joined something from MySQL and something from Oracle and just expose it as a very easy to use OData service. The version of Teiid that we use is the Red Hat version. If you know Red Hat, they'll put their sticker on an open source product and sell it to you. What they're selling to you is the support and the guarantee that if something's broke, they're going to fix it. So at the medical school, we don't like to go down the road of working with unsupported systems. We like to know that there's going to be a vendor behind that to help us stand up any kind of resolve any kind of issues that might come up. And so we use a Red Hat version of data virtualization. And the reason that we initially were the biggest reason we were interested in this was its ability to kind of serve as a back-end data source for quickly creating web services for a service-oriented architecture. One of the big things that our group does is we stood up a service-oriented architecture for the medical school that it sort of allows for commonly used research data to be exposed as web services. And this is currently a component at the back end of an application called Data Direct, where researchers can come in and say, I want to look at the health system. I want to find white males between 40 and 50 that are slightly overweight and have blue eyes, any kind of data that you want to integrate in one place. But then they also have a biospecimen in the biorepository. They may have genomic data available. And so what we do is we've taken the data from the central biorepository and we've surfaced those as a web service to where Data Direct can say, I have this cohort of 400 patients that a researcher is interested in. Do we already have a specimen on hand that that researcher can use? And we also capture waveform data, metadata, so that when they say, I'm interested in this set of patients, do they also have data for pulse ox information over time? Any kind of waveform data that we've captured in the health system, we can expose that to that interface as well. So in terms of our initial interest in data virtualization as a system, it was really a way for us to accelerate the way that we can connect to data as part of MedBus. What I'm going to talk about today is a work that we did with Srijan, which is a very interesting use case as well. If you think of the sorts of data that he described, there's a number of different types of data spread across a lot of different places connected on a mix of patients. And it's a very good example of the sorts of data that we're going to get into when we try to look at how do we support precision medicine initiative. If you look at that, it was one of the things that got funded as we transitioned between governments that we're going to try to build out a 1 million patient cohort in this thing called an All of Us data set. And that's going to be 1 million patients where they're expected to collect up to 20 terabytes of data on each patient. So if you look at what that would look like, that's about 20 exabytes of data. That gets to the point where it's not really possible to push all that data into one single location, and we need to think about what are different ways that we can access those data in a meaningful way, whether distributed across a lot of different places. And so this has been a perfect example of what would that type of system look like, where we want to aggregate data and ask new questions when we can't even have it all in one place. Now, one of the first things we did for some of these text databases is we kind of cheated a little bit. And instead of connecting to an XML file, or instead of connecting to a text file, or instead of parsing an entire genomic data set all at once, we did some sort of pre-processing, parsed out some of that metadata, and shoved it into a MySQL database. And that's mainly for performance reasons, so that you kind of get a faster index of that kind of data. One of the nice things about data virtualization is you can shove all these things in there and say you don't really know what all types of data you might need to store about a given study. You can just study it, throw it into your database as sort of an EAV data store where you have an entity, an attribute, and a value associated with it. If you've ever worked with those sort of data, one of the things you run into is in that value column, you might have categorical data mixed in with numerical data where you need to store it as an integer and some of them as ratios. And when you go to try to analyze that, you got to pull those data out and create a metric where your numbers are in a number column, your categories are in a category column. So what this can do is you can kind of shove all those data and be sloppy on the back end, just storing it in a database. And the DataVirt component can do the piece where you pivot that data out and you put your numbers in the number column, and it can present it to your analytical environment like SAS or R so that it knows that that's a number. And you don't have to figure out how to convert those text values to numbers and that kind of thing. And then on the back end, you can just keep shoving whatever data you want into the system. And then on the front end, you're able to use those data in a way that's actionable immediately in whatever your statistical analysis environment is. Now, in addition to that, we also have data in two other systems that are in other relational databases. One's the location data and the mood data that's being captured by that mobile application, and that's going into an Oracle database. And there's also data that are in a REDCap database. And what we do in Dataverse is we take those three physical databases and we convert them into a single virtual database. And an analyst is able to connect to those data just as a virtual database using a SQL front end, using something like Squirrel, where you just connect to it via JDBC connection. And what that looks like is that these physical databases are described in the data virtualization framework as an XML file that just kind of describes the metadata of that data source, where it is. That's where it knows where the data is. It knows what the data types are. And then the virtual database that sits on top of those is also described as just an XML file. So that's where you can pivot things out. You can tell it that this data type's a number when it's stored in the database as text. And that's the front end that the end user would see when they go to connect to these underlying data sources. Now you can edit these just sort of manually, just with a regular IDE, but then they also make an application that called Teiid Designer that provides a graphical user interface for dragging in data sources, understanding what the data structures look like, as well as doing the conversion among the different data types. And that's just an Eclipse plugin where it just presents the virtual databases as these orange boxes of data, the physical databases as these blue boxes, and you're able to talk about how these data fit together. We don't use Eclipse a whole lot in our group. We just, some folks use IntelliJ, or I use Emacs, and we just edit these things by hand and then use GitHub or Git as a way to kind of share the way that we've presented these data, and then use that to publish these data to the virtual database server. So you create these virtual databases, they get deployed to this Teiid server, and the Teiid server does the hard work of, when you write a query in generic SQL, it'll push it down into the native languages of the different underlying repositories. So you don't have to think in Oracle, you don't have to think in SQL Server, you don't have to think in Hadoop. You just write your SQL query, and even the developer that creates these virtual databases doesn't think about how to optimize the data. The system itself does a good job of doing that. And when you launch a query against a virtual database, it'll push down the subqueries to all those systems underneath, pull them back up together, and then send an aggregate query result back out to the user. And when you use the IDE, you really don't have to know how to do any kind of coding. You don't have to be a Java coder or a SQL coder. That helps. It's enough of a graphical interface where you can kind of drag and drop these things together. But at the same time, it also has the capability to throw in bits of code on top of your view of the data. For example, say you had a data set where you wanted to provide location data by zip code, but you weren't able to provide a zip code if there was less than 1,000 people in that location. So one of the things you could do is that you could join that zip code data set against another table that has the population, and then you can scrub out the last few numbers that would be necessary in code within the virtual database, so that your database at the underlying layer is identifiable data, but you could expose it in a way where it's de-identified, to where you're not having two copies of identified and de-identified data. You can have the de-identification process be something that sits on top of the data itself. And then once we create these virtual databases, they just get deployed to the JBoss data virtualization server. And then the user just accesses this like they would any other data set.
Has that de-identification been validated?
Has it been
valid? Times when you can take some of that data off. Like
oh yeah, you can.
But there's still enough information to pin it down to specific people.
Oh yeah, yeah. So you could, you can meet the requirements of safe harbor for how you clean up the data and make it officially de-identified, but you can usually find ways to attach those data to other systems. And that's one of the things that worries me a bit about using Datavert as a way to integrate data. Sometimes when you have a research database that was created for a specific question, the process you use to intake that data may have said that I'm never going to add these data to other data, that they're going to sit there where they can't be, mixed together. And so that's the ability to take into account how the research subject said you can use the data is a very important part of how we do these types of integration. And then there's a group here on campus that's doing some interesting work where they're thinking about how can we create an ontology of what that looks like to where we can have a computable process for intake of data to where we know 10 years from now how those data could be used in different types of researches, questions. And that's one of the big things that we're trying to enable as well, and that this is an example where the primary data collector has primary questions that his team wants to ask of those data. There are other situations where we have secondary uses of those data, and how those are used really needs to take into account, situations like this. What's the level of identification, the risk that we're willing to accept, and what's the level of integration that's allowed under the paperwork that the patient signed.
I'm struggling with the geolocation. Identify.
Not only that, it gives you a lot more information if you're tracking their activities over time.
Yeah.
It's not just.
Yeah, then there's a great example where they published taxi data in New York City, and they were able to bring that together to identify clubs. Yeah, and then specific clubs they might not want their spouse to know that they frequented, and so these are things where you've got to really take that into account. And yeah, so just because you can doesn't mean we should, and with a lot of this stuff. So the way that the endpoint of the data integration that we did with Dr. Sen is we have a little over 50 different tables from it's about 10 or 12 different data sources that really just kind of all look like they're sitting in one place, to where the analyst can just log in and then make these joins across genomic data sets, the hair data sets, the how are you feeling today data sets. And you don't have to spend time pulling those data in and doing these merges in one-off sessions. They just kind of exist all together in a virtual database. So that when you look at how you connect to that, you can just connect to it via JDBC, just using this thing called the Teiid JDBC driver, just like you would any other MySQL or SQL Server JDBC connection. And you just ask questions of the data like you would a regular database. You can just do how many participants have location data available just as a straightforward SQL database. So this is a connection to that live data set that's streaming out from the iPhones that's loading into Oracle. We can ask questions of those data immediately. And we can also ask questions of, how many participants have location data and mood data available. So just right away, you can start to know, basic things about your data set. And then when you know how you want those data to be structured for your analysis, you can either create this query and make a file that you then send on to SAS, or you could connect directly via ODBC or JDBC to your analysis environment and push that query down to where you're not having to do all the data munging on a system like SAS or R, that you can do that stuff at the virtual data layer so that you can push out an analysis-ready data set directly into your analytics environment. Another nice thing that it does too is that when you send this query down into the system, it'll audit who asked what of what data when, and it knows what you asked of the data set as well as what the query that was pushed down to the underlying systems. So again, so a lot of these secondary use data types where we're asking questions of data that may not have been collected primarily for research purposes, we're able to say later who accessed an individual's data and under what research context. And we even have systems that allow us to know what IRB that they asked those questions under if we want to track that as well. So that's mainly what I had to go over today. If you have questions, you can just email me directly. MedBus is something that we consider an open source project. It's an Apache, a licensed thing that we're willing to work with folks in the university that are interested in integrating service-oriented architecture, web services in their work. With Teiid, you can look at the free version right away. If you're interested in the supported version, we can have a conversation about how we could enable that and the sort of work that you want to do. And if you really want to get a hands-on feel of working with data virtualization, they got a Hello World example, which will allow you to kind of install the environment and be up and running with it within 30 minutes. So yeah, to me, the great things about it are it's this massively capable engine. The front end they have around it for developing is a little bit not so good. Like a lot of things Red Hat does, they'll focus on the infrastructure and not so much on the interface pieces. But I think the engine itself is very, very strong. When it pushes down a query where you just write something generic in SQL and it goes out to the underlying system, it does a pretty good job of optimizing. So, an Oracle developer can write Oracle code that works much better than a SQL Server developer trying to write Oracle code. There are little tweaks you can add. The system seems to be able to do that pretty well. There's only about a 1 to 2% overhead in time it takes to run a query going from this generic SQL query to something that gets pushed down. I've used it to create these OData services, and that works really, really well. And it's been pretty good. It's just that interface in Eclipse I find not very good for developing. I'm not a huge Eclipse fan anyway, but that seems to be its biggest weakness. So when you get the Hello World example, if you like Eclipse and you can push out something pretty quick, that gives you a good taste of the sort of things you can do with DataVirt. Any other questions?
Quick question on the intern thing. Once they've finished internships, they go into different specialties. Stratify by that and also look back at what their record was like when they were interns. In other words, do they select specialties based on kind of some personality traits? And I would also expect that there would be, once you get out into specialties, like some are known for being like really high stress, like pediatric oncology.
Yeah.
So
Yeah. So they select the specialty before they start internship. So you decide that while you're still in medical school, but everyone kind of has a common internship experience for that 1 year, and then they go off to different. So we've been following like a subset of them, maybe 800 of them, beyond just the 1 year as they go into specialties, and we see some pretty big differences. So yeah, you had a lot of interesting questions in there. We see some really big. So dermatologists, their depression goes back to like below population baseline levels. They have very little depression, but obstetricians, neurosurgeons got really more depressed after internship. So overall, the depression rates are like 25% at the end of internship and go down to 12, 14% in years 3, 4, 5, 6. But there's a lot of variation by specialty. There's stuff during internship that predicts outcomes 5 years out when they're in specialties. So getting depressed during intern year predicts being depressed later on. And sort of interestingly, one of the issues.
Is that true for general populations? You've been depressed once you have a higher tendency later.
Yeah. So the strength of the prediction is bigger here than the general population, but the overall finding is general. It also predicts there's a big gender difference in not working in medicine. So like out of those 800 people, it's about half and half. 399 of the 400 men are working full time in medicine. One of them is focusing on kiteboarding. But the rest of them, kiteboarding. It's calling that. Yeah. but something like 30% of women 5 years out of training are working part-time, and 80% of the ones who are working full-time are considering working part-time.
Yeah.
And most of that is not kiteboarding, it's work-family
I
conflicts.
know. That happens in a lot of
Yeah.
non-medical.
Right. But the being depressed during intern year predicts.
Which group they'll fall into?
Yeah, predicts if you're going to be working part-time 5 years out. So, and then there's but sort of along the lines of what you're saying, there's interesting connections we can make between their depression experience at 25 during the stressful intern year, and then outcomes in psychopathology and in work conditions, things like that, several years out. Which, yeah, again, most of the stuff wasn't part of the initial hypotheses of the project, but are coming out of the data. If we can find like other methylation stuff that mediates it or DNA.
You showed the iPhone app and you were asking them to respond on their mood. Did you say you asked that once a day?
Yeah.
I'm a little surprised that once a day is enough to find out much about the spectrum of how they're feeling today. And two, is that like randomized? Because I'm guessing it also very much depends on the time of day it's asked.
Yeah, it's not. It would be better if we did it multiple times a day, and we tried to randomize a little bit, and we found our response rate went down a lot. So we get, so we let them choose the time of day, and they get it at the same time every day.
Okay.
So there's limitations of that data. Certainly, we'd like to, but when they're in the operating room most mornings, if they get the notification at that time at 11 a.m., they're not going to respond. Mm-hmm. So we find the response rate is better if they get it at a time so most of them set it between like at 6 p.m. or 8 p.m. and get the mood every day. So it's not as good as a random time for in some ways, but I think it still gives a lot of information that traditionally we in this study in psychiatry in general just get mood scores at every 3 months when they come into the office, or that's how we've been doing it here, and the daily mood is a lot richer. Some people are steady at like a mood of 6 throughout, and other people are jumping up and down, and there's important differences there, and we see that when Daniel Kahneman's a behavioral economist, has done some cool stuff around the peak end theory. So he found that when you go on vacation, if you ask people how their vacation was, they're not giving you a mean score of their 2-week vacation. They're giving you their best day of vacation and what they're like today. And we kind of find the same thing with this daily mood stuff when we ask people with the PHQ, the longer questionnaire that's asking about the last 2 weeks, how your mood and sleep and all that has been. But when we look at that in comparison to the daily mood data, what these interns at least are saying are not giving you a median score of or a mean of their last 2 weeks of mood. They're just remembering their worst day of the last 2 weeks, and then a lot of it their mood today. And so by just asking at 2 week or 2 month or yearly intervals, you're probably not getting a good measure of their overall mood over a period of time. So the daily mood gets at that.
You get kind of tired of it and just start going 6, 6, 6, 6, 6, 6.
Some of them, yeah. So there's
like it's easy to not think about it. Gee, how did I feel? 6.
I mean, yeah. Some of not as much of that, or they just don't do it anymore. So people get tired of it and drop out, and there's probably some bias among the people who keep doing it and people who don't. Yeah, it seems to be more that an issue than putting the same score.
Because I know sometimes when I got really annoying polls, I do things like patterns.
Yeah. I think that's
another one of these. Okay, fine.
Right. I mean, since there's a lag between, you don't get it like you're not doing it just repeatedly. So, but I think getting people to do it.
How in the world do you stand like? What's a 5 for everybody? Like how?
Yeah. So I think it's most.
You just have to do trend from within within a person.
Yeah.
Kind of, right.
So what their score is before the stress starts, and then how that changes with the stress. So it changes. Yeah. So it's most useful in reference to themselves, right? Because 5 for you is different than 5 for me. Who knows what
It's like when they ask me on a scale of 1 to 10, how much is it?
right.
What exactly is?
Right. Yes, people. Yes. As a doctor, that's much more useful once people have given birth to a child. That gives a standard.
Well, that cuts
That's-
out half of your.
That's 10. What's everything else?
Yeah. So that pushes down the scale. I
least-
found. What?
That takes out half the population of candidates.
Yeah.
Or more, actually.
Yeah, that's a general problem with psychiatry. In that all of our stuff is subjective. So, kind of some of the exciting stuff with this mobile data, if we figure out how to use it, is that we'll have some objective measures that might be a little more, robust than the subjective stuff.
What percentage of your study participants end up dropping out throughout the year as they start getting stressed and depressed, and then
Yeah.
filling out the surveys are just one more thing for them to do?
They tend not to completely drop out, but for each, so about 61% sign up for the study that we invite, and then at each time point, about 70% of them respond to the larger survey. So which was good, and there was at least some. So people would sometimes skip the September survey, but then do it in December, and then the rates were pretty similar across the year. With this mobile stuff, when we're asking for daily mood, we found in general the rates were pretty high for the first 2 months of the study, and then as it went on and on, people dropped out. So the thing we're working on this year is to give people more feedback. So in retrospect, what we were doing to them last year was kind of cruel. We were just asking them for their mood and gathering their activity, but we weren't feeding any of that back to them. So there was absolutely no positive reinforcement for entering the data. So now we're going to give them access to their data, and then we're working on sort of putting together sophisticated graphs of how their sleep and mood relate to each other. So, and then try to pull out some insights to try to make it useful for them beyond the whatever $50 we give them. So, but I think that persistence stuff is hard with as we're asking more and more of them.
I think there was another question, which is their bias because of she said people in the bad mood particularly start to self-censor or something.
Yeah, no, we don't see, at least from the quarterly surveys, we don't see that too much. Like the people we can predict about 65% of the variance who's going to get depressed, and there's no bias between if you're likely to get depressed and dropping out of the study than if you're not likely to get depressed. So it doesn't seem like the depressed people are the ones preferentially dropping out. Men are a little bit more likely to drop out. So there's some demographic stuff, but not by depression.
Curious, what sort of responsibility, if any, do you have, or response can you have if you identify someone who is severely depressed or has suicidal ideation, or is there anything you can do in this circumstance?
It's a big, we thought about that a lot, and it's hard to, there's a lot of stigma around this in this group, so they wouldn't respond honestly if they thought we could identify them and hospitalize them if they're suicidal or something. And also it's really prevalent, so we have 4,000 subjects a year, and any given time 8 to 12% have suicidal thoughts. And there's some delay in getting the data. So sort of the compromises we've come up with is to just provide everyone, so we know both national resources like suicide hotlines and then local stuff on their emergency room and some providers who will see them for free. And we provide them that information with each survey, and sort of hope that the ones who need it will will avail themselves of the resources, but don't ever don't have the capability of intervening on an individual basis. So yeah, we've kind of found, so we've done some stuff on developing interventions for them, and it seems like this population really likes to sort of manage their own problems and take care of themselves. And we found that the people we are in this mobile part of the study where they are asked every day about their mood and wear Fitbits and stuff like that, those people get half as depressed as the people who aren't in that part of the study. And we're still trying to figure out why some of the different micro-randomized feedback is to get at that, but it seems like they're able to make connections about why, on the weekends I'm a lot less depressed than the weekdays, or every time I have to go to this cardiology clinic, I get really bummed out, and then sort of arrange their life or get some feedback from that helps them protect against that in the future.
Just something just about the tracking or the awareness itself is protective.
Yeah. Feeling like there's someone out there who cares that someone said that. So yeah. But there seems to be something about being in that part of being tracked that closely that is therapeutic.
Any other questions? Okay, well, thank you very much.
Yeah.
Getting into it. Again, that's a combination of mobile stuff.
Yeah, there's a at Michigan State who's doing the mobile.
Recently hired someone.
His contact. So he's developed a mobile app. So you in terms of
So we never got into.
He was just talking about the consent ontology.
it might be a good
Yeah.
part.
Now,
Yeah, so it might be worth it.
He's got an award recently.
Marcy
That app
Harris involved in the consent
specifically, because he
ontology.
predicts depression
I think
based on movement relaxation.
Yeah.
I haven't met her yet.
Oh, you haven't met us here, so.
Yeah.
Yeah, that sounds. Yeah, exactly. Yeah, I have no idea how to do that.
Yeah, so he might be a good
And then I wanted to mention
He's not here.
month where the depression center is where most of the outpatients are. So we're just starting to got pulled into the Michigan Stories. So we're collecting DNA from all the patients. Proton. You're one of the few. We'll provide a DNA sample, and then so it should be 5,000 subjects beyond that. So that would be really useful to use the MedBus to try to.
Yeah, so we've got it. So we're connected to those data in the biorepository, so you know where the specimens.
Right.
Well,
I know you
hopefully,
can connect it to patient.
Okay.
So we've already got that piece.
Cool.
So you didn't want to do the genomics part now.
Okay.
they're getting
So
that.
so we'll have they'll all be in the repository, and then
They haven't
all
done
their clinical information should be.
Yeah, no, if you're
Yeah,
enrolled in
that's
something like that,
That's one of our.
you like get considered.
Really? Okay.
You're already scheduled for
Yep, sorry.
MRI, you go
Okay.
in and I say, oh, do you want to get a study, and then you sign right
So I
there.
think a lot of them like first FMRI, those are done.
Cool.
Yeah. Yeah. So that should. Yeah. That should be.
Yeah, the MGI.
Functional. That's where they can track.
Really? Okay. Good. Good.
Oh,
There's
okay.
different
Leg up, they use
outside of the primary question you're interested in.
Yeah.
For getting data set. Pain management.
Really sucking in
Right.
I think was drive down costs.
That's how they
Some
do
of
it,
that's
where they show like
data.
part of brain lighting up.
Oh, yeah,
Yeah.
like
Yeah.
frontal cortex.
Yeah.
Active because.
Or this little nucleus is doing
Yeah.
something now.
Yeah, when the
Okay, I didn't know that's what.
the consent for that's pretty broad.
Yeah.
Sometimes.
So I heard that they were really surprised.
Oh, okay,
how
yeah.
much to read eventually.
Yeah. Yeah. It's like.
Yeah, I'm familiar with
Yeah.
that.
It's a really short.
It's a huge,
consent.
yeah. Well, and
Like
then
it's been really broad.
very few people withdraw consistently.
Yeah. Yeah. Exactly. So it's great. Yeah. So it's a really.
Yeah.
Hey. How are you?
Hi, I just wanted to ask you one thing.
Awesome.
Basically, a lot of what you showed, are you differentiating between normal fluctuations in mood and
Okay.
the official definition of depression, whatever that is? Or is all of this not real? I mean, are all these people not really depressed? Are they just Sorry, do you know what I'm getting at? Yeah, I mean, because depression is usually defined as an extended episode, and
Yeah, so if they, with the daily stuff, it's hard. It's for the PHQ, which we ask every 3 months.
Right.
There's their standard
right.
scoring threshold. So having a score of 10 or more, and then there's a question if you